find the equivalent resistance between the terminals A, B, C. So let us assume that the networks, the terminals A, B, C are connected to some part of the network. So here we need to find out the equivalent resistance between the terminals A, B, C. We need to find out. So if you look into a circuit diagram, so here there is no series parallel combination does not exist. So we need to apply the star delta network transformation, and we have to reduce the network into the simplest one we need to reduce. So what shall we do is, so there are two part of the networks are there, two types of networks. One is the delta network. The outermost one is the delta network. Here it is. And innermost one is the star network. So what we'll do is, we'll consider the star part of the network and we'll convert into the delta form of the network here. So we'll consider the star, consider the star network, and we'll convert into the delta network. We'll convert here. The star network is, so it consists of the 4 ohms. So between the terminals A, B, and C, this is we are going to convert into the delta network. So this is the node A, node B, and node C. So this one we are going to convert in terms of the delta network. Here we need to find the values for the resistance RAB. So between the node A and B, that is called as RAB. Between the node A and C, it is called RAC. Between the node B and C, it is called RBC. Let us find out that one. The value for the resistance is 444. So RAB is nothing but, so it is nothing but the product of the 4 into 4 plus 4 into 4 plus 4 into 4. It is nothing but, it's a product of this one divided by the opposite resistance. So it will be equal to the 4 into 4 plus, so 4 into 4 plus 4 into 4. So whole thing divided by the opposite resistance, which is nothing but 4 here. So this value is nothing but 16 plus 16 plus 16. It will become equal to the 48 divided by 4. So this will become equal to the 12 ohms we'll get. And also the value for the RBC is also same, and RCA is also same, because all the parts of the network is having the same values is there. So this is RBC, and this is also equal to the RAC. All the part of the resistance is having the same value. Now what we'll do is, so between the node A, B, C, the star network can be replaced by this delta network. So I'm going to write the network here. So first let me write the network. So between the nodes A, B, and C, so we have this part of the network. So this is the original one where we have here. So this is A, B, and C. The value for the resistance is, it's a 4 ohm, and this is a 4 ohm. And between this one, we have the delta part. We have replaced the star with the delta network. We replace with that one. So this value is equal to the, it's a 12 ohm, and this is also 12 ohm, and this is also 12 ohm. So now if you look here, so between this 4 ohm is in parallel with the 12 ohm, and the 4 ohm parallel with 12 ohm, and 4 ohm parallel with the 12 ohm. So we'll get the equivalent value we'll get here. So the equivalent value we can do replace between the nodes A, B, C. So this is the node A, B, and C. We can replace here. So that is the 4 ohm parallel with the, so 12 ohm. So this is become 4 into 12 divided by, so 4 plus 12. So this will be the 48 divided by 16. So we'll get equal to the 3 ohm we'll get. So this is the 3 ohm, this is the 3 ohm, and this is the 3 ohm we'll get here. So this is the equivalent network between the terminals A and BC in terms of the star delta conversion. We got this on this, we got here. So like this, any part of the network we can convert into a simplified into by applying the concept of the star delta transformation. Now let us consider the one more problem we'll consider, where similar kind of the circuit will be there. So let us consider the problem number 2. So here also we need to find out the equivalent resistance between the terminals A, B, C. Equivalent the resistance between the terminals A, B, C. We need to find out here. So this is the star delta part of the network is given. Again, one more delta part of the network, and many star networks are there. So what we'll do is, so here we have the RABC, ABC is there, and also the DEF is there. So I'll consider the delta part of the network inside the DEF, and we are going to convert into the star network. We'll do convert here. So we'll consider the consider the delta network. So we'll consider the delta network. So between the terminals DEF, and we are going to convert in terms of the star network here. So DEF I'm going to consider between the node AB and DEF will consider. So this one we are going to convert in terms of the star network. Let us convert here. So this is the DEF. The impedance, the resistance value will be equal to the 4 ohms. And this one you are going to replace with the star network. This is the star network. The value for the resistance is RD, RE, and RF. So this is RD, and this is RE, and this will be equal to the RF. So we need to find out the equivalent impedance RD, RE, and RF. We need to find out here. So the value for the RD is nothing but, so it's a delta star network. So it's a product of these two resistances divided by the sum of all the resistances. So it is 4 into all the restances 4 plus 4 plus 4 here. So 4 into 4 is 16 divided by the 12. So it will become equal to the 4 by 3 ohms we'll get. 4 by 3 ohms, or it is almost equal to the 4 by 3 ohms we'll get here. So it is equal to the 1.33 ohms we'll get. So this will become equal to the 1.334 ohms we'll get here. So since all the resistance are having the same values, so RD is equal to the RE. This is also equal to the RF, which is equal to the 1.34 ohms we can consider here. Now what we can do is we can replace the network between the DEF with the star network. We can do replace. So we'll replace that one here. We'll replace that network, that part of the network we'll do replace. So what I'm going to do is I'm going to draw the network between the ABC. We'll draw it here. So this is the network between the A, B, and C. Will plot it. And between that one, we have the one more resistance. And this is the D, E, and F we have. So here we are going to replace the star network. We are going to replace here. So the star network is, this is a star network. The value for this one is, so 1.334 is all the values is having the same value. So this is the 6 ohm, and this is all the resistance is having the 6 ohms are there, and the corresponding resistance are 8 ohms, 8 ohms, and 8 ohms are there. So this is the node A, and this is the node B, and this is the node C. So here we need to find out the equivalent values. We need to find out here. So here this is a 6 and 1.334 is in a series, and even 6 plus 1.33, this is also 1.334, and this is also 1.334 are in series here. So we can find out the equivalent value, and again we need to apply the star to delta transformation, and we'll convert this one. So this network will become equal to the, so the outer layer, the delta network will remain same as it is. And the inside one, the star network will get. So this is, it is similar to the previous problem what we consider. We got the same value we got. So this is the, it is 7.334 will get. This is also same thing, 7.334, and this is also the same thing we'll get. And this is the node A, and this is the node B, and this is the node C we'll get. So here these terminals are node A, node B, and node C. So again we need to consider the star network between the node ABC. So we'll consider the star network between the node A, B, and C. Between the node A, B, and C we'll consider, and we'll convert into the delta network. So this star network is nothing but, it's a 7.334 is there. So all the values is 7.334. and this is also having the 7.334. So this one will convert into the delta format. So the delta network will consist of, this is a delta network. We need to find the values for this one. So this is the node A, node B, and node C. So this value is nothing but RAB. So this is RAC, and this is equal to the RBC. Let us find the value for the RAB, so which is also same as the RBC, and this is also equal to the RAC because all the values are same. So we'll find out that one. So RAB is nothing but it's a product of the all the elements divided by the opposite resistance. So it is a 7.334 into 7.334 plus. So the 3 times we can. So just we can multiply with that 3 divided by the 7.334. So one will get, this will get cancelled. So the what the resistance value we got is, so it is equal to the 7.334 multiplied by the 3. So it is 22 ohms will get, that's the value for the RAB. So this will become equal to the 22 ohms will get here. So we can replace this part of the network with the 22 ohms with the each one. We can do replace. So we'll do that one. Let us do it. So what shall we do is, so this part of the interior part of the star network will be replaced with the delta network. So we have, I'm going to write the outermost star network will write here. So this is with the 8 ohms. This is with the 8 ohms will write. And parallelly to this one, we can do replace with the other delta network. Another delta network will do replace. So the values between this one. So we can see the resistance is 22 and 8 ohm will come in parallel. So all the resistance are 22 ohm. And this is 22 ohm, and this is the 8 ohm resistor. And these are the terminals, which is A, and this is B, and this is equal to the C. We need to find out the resistance. So you can see 8 parallel with the 2 ohms will get here. So that is RAB is the limit. So 8 parallel with 22 ohms will get. So the value for that one is, so we'll get as, it will become equal to the 5.86 ohms will get here. 5.86 ohms. So the circuit will become equal to like this will get. So where the terminals are connected. This is a node A, node B, and node C. The value for the resistance is, let us assume as 5.9 ohm. So approximately we can write as a 5.9 ohms. We can reduce. So this is how we can convert a complicated network into the simplest form we can do convert, and we can able to obtain the solution for the given network. So this is the where the concepts star delta network transformations we can use, and we can reduce the complex network into the simplified one we can do reduce here.